today's topic is solving multi-step equations. Right, we're going to put what you know about solving one-step and two-step equations into a little bit more complex of a realm. And I really want to focus on this learning target today. I can remember the distributive property and combining like terms when solving equations. And this really is about remembering. When you see an equation that looks kind of complex, it has parentheses, it has more than one x, all you really have to do is remember these skills that you already know, and then put them to use. So let's just quickly review. The distributive property says what? Does the distributive property say? Yeah.
When combining like terms, never mind.
Remember it? You were thinking of like terms, which is what we talked about yesterday. 2 days ago, we learned the distributive property. Look back in your notes and find it. What is the distributive property? Yeah.
I remember what it's the thing where
No, look back in your notes and find it. Look in your notes and find where we said distributive property. Yeah.
The distributive property is where.
So find it first, and then.
Yeah, I have it.
Okay.
So like A times B plus C in parentheses. So like A in parentheses, B plus C in parentheses equals A times B plus A times C.
Yeah. Right? And the way that we sort of remembered this is with our little rainbow.
Yeah. Woo!
A times the B, A times the C. And that allows us to get rid of parentheses, which we need to do because when we have parentheses, PEMDAS says we can only do what's inside them. We can't combine them with things that are outside the parentheses. But this will allow us to kind of eliminate the parentheses, eliminate that step, and combine like terms. So combining like terms refers to if I have something like 3x plus 5 plus 2x. First, I have to identify which terms have the same exact variables. So in this expression, which terms have the same variables?
3x and 2x. So you
Good.
circle them. And you put a square on the 5.
Right, and 5 is different. And then I just combine the 3x plus the 2x, and that would make 5x.
Plus 5.
And then this term just stays, right? And we can do this even if there's like an equals 7 on the other side, right? I could still combine like terms if this were equal to something. So what I want you guys to remember is we've been dealing with expressions for the past couple of days. Now we're moving into equations. An equation is just two expressions. It's one expression equaling another expression. All right. So let's look at a sample problem. And this will be a problem from your homework.
So we write the answer down.
So if you write it down, it will help you when you get started on your homework this evening. Let's say we had 3 times 2n minus 1 equals 15. Here's an equation because it has an equal sign. This equation is made up of one expression over here, one expression over here. What am I going to have to do in order to solve this?
Distribute property.
Yeah, I have to distribute the 3 across those parentheses.
Rainbow.
So 3 times 2n is going to be 6n. 3 times minus 1 is minus 3. The 15 doesn't change, right? That's on its own side of the equation. This equal sign is like a concrete barrier, right? It separates these two halves of this equation. I can
Subtract
move
3. Or add 3.
Something
Add 3 both sides.
from one side of the equal sign to the other side by adding it over here and also adding the same thing
And
over here.
6n would equal.
Right.
6n equals 18.
So here I have 6n. 15 plus 3 is 18.
Then divide by 6.
Now I need to divide by 6.
And
Which
that
is
gives you
3.
n equals 3.
N equals 3. And that's going to be our final answer for that problem. If we want, we can test this. I would highly recommend you guys do this, especially on quizzes, by plugging it back in. So if I had 3 times 2, I think that n is 3. So I'm going to write that instead. 2 times 3 minus 1 equals 15. Now I have some options for solving this.
3 times 2.
First, PEMDAS says to look at what's inside the parentheses. So let's do that. 2 times 3 is 6 minus 1. And 6 minus 1 is 5. So now I have 3 times
15
5
equals 15.
equals 15. Is that true?
Yes.
Yeah, that's true. So this is just to check my answer here. Alright, let's look at another problem. Can I erase this?
Yes.
Yes.
Boom.
Okay. Let's, oops. Wrong sheet. Let's take a look at this one. What if I had something like 3x plus 2x plus 2 equals 12? What am I going to have to remember in order to solve this? Yeah.
No. Oh, remember? Or
Yeah, what do I have to do?
you add 3x and
Yeah, I have to remember that these are like terms,
like terms.
right? Now, is this a like term
No.
with this?
Yes. Yes, it is with that, but not with
It
that.
is, but how come I can't combine the 2 and the 12?
Because they're on opposite sides.
They're on opposite sides of the equal sign, right? So when I'm combining like terms in an equation, I'm only doing it on one side of that equation, right? I'm not going to try to combine the 2 over here with the 12 over on that side. So 3x plus 2x are like terms that are on the same side of the equation. So I can combine those to make 5x
plus 2 equals 12.
plus 2 equals 12.
And then you can subtract 2
Subtract
from
2
each side.
from both sides of that
And
equation.
that gives you 10.
So 5x.
X equals 10, and then you divide, and x equals 2.
Very good. Divide both sides by 5. X equals 2. And that's all there is to it. Now, when we get to right here, this is just, what did we call these? 5x plus 2 equals 12. What was our name for that sort of a problem? Starts with T. We call this a
Two-step equation.
two-step equation. So this is a review from here down, right? I'm subtracting this from both sides. I'm dividing by the coefficient. But it's kind of getting the problem to look like that. This is what's new. Sometimes we're going to have to combine like terms. Sometimes, like in the last example, we had to distribute. And sometimes, like in our next example, we have to combine like terms and use the distributive property. So if you had a problem like this, 2 times x plus 4 plus x equals 41. What's an approach to this problem that might work?
Distributive property.
Distributive property is a great first step. That's going to let us get rid of these parentheses. So if I distribute the 2 across the things in parentheses, I have 2 times x, which
2x
is
plus
2x. 2 times 4
8 plus
is 8.
8.
Does the
Plus-
2 multiply times this x?
No,
Why not?
because it's not in the parentheses.
It's not contained in those parentheses, right? So the 2 affects what's inside these parentheses. Equals 41. Okay.
Now you can add circle 2x and x.
now I can combine these like terms. 2x and x are like terms that are on the same side of the equation. Right? So what is 2x plus x?
3x.
That's exactly right.
Plus
I also
8
have an 8 over here,
equals 41.
and I also have a 41 over there.
So you can subtract 8
Nice.
from 8.
Subtract 8 from both sides of this equation. 3x plus 8 minus 8 is just 3x. And 41 minus 8
Is 33.
is 33.
And 3.
How do I get just x alone?
You divide.
Yeah, divide by 3.
3 goes into
3x divided by 3 is
11
x,
less
and 33 divided by 3.
11.
Nicely reasoned. X equals 11, right? We started with this complicated looking thing, and we just simplified it down to x equals 11. We solved for x. What did we have to use? Distributive property, combining like terms. So 2 skills that we just practiced. Let's do one more.
Wait.
Okay, I'll write it over on the other side.
Yeah, I got
While you're still
You can
right.
always go back and look at the video.
This one, so this last one, guys, is not going to be something that is not going to be a problem from your homework. Okay? This one's going to be a little bit different.
Does it have distributive property?
Yes.
Oh.
2 times.
2.
Okay, you can erase it now.
All right. Let me make sure that's okay. Here's our problem. What's our first step? Yeah.
You did a distributive property, so you do 2 times n and 2 times 10.
Good.
Negative 10.
2 times n is 2n.
2n.
I'm going to keep the minus sign,
It's just negative 20.
so I have 20. All right?
Plus n minus 3 equals negative 23.
Right. That's all unchanged, right? We just changed what's in the parentheses. Okay? Now what? Still looks a little complicated. What can I do?
You can do the circle and
So what should I circle?
should like terms, yeah.
Uh-huh. Which ones?
The
2n and a 9n.
2n and 9n. Nice. What else could I combine? Does anyone see any other like terms
The
here?
minus 20, minus 3, and is the negative 23 a part of that?
Great question.
well, it's
Can
on
I
the other
combine the negative 23 with these
side. No.
other
It's on the other
constants?
side of the equation.
It's totally apart because it's on the other side of the equation.
So 2n
Alright, so
plus
I circled 2n and 9n because those are like terms.
11n.
That's going to combine to give me 11n. And then I boxed negative 20, or minus 20, and minus 3 because those are like terms. When I combine those, what will I get?
23.
Very close. So I have minus, and then minus even more. I have 2 negative numbers combining together.
17. Negative 17.
Super close.
20 minus
If I had minus 20 and plus 3, that would have given me negative
23.
17.
Negative
3.
23.
Negative 3.
Negative 23.
Let's look at this. Let's look at this on a number line, right? So here's 0. We're down here. I'm not actually counting, but we're down here at negative 20. So way over here. I want to go minus 3 from there.
That's negative 23.
So I'm going to go 3 more in the minus direction.
23. Negative 23.
Yeah, this would be negative 21 here, negative 22, and this would be negative 23.
Yeah, so.
Didn't we say negative 23?
Yeah, I said that.
Among many
said
other
that.
things. Alright, equals
Negative 20.
negative 20.
Oh.
What am I going to do here? Yeah.
Add 23.
Add 23 just here?
No.
is 11n minus 23 plus 23?
11n equals 0.
11n. What is negative 23 plus 23? You just said it.
0. And you can't really divide 0 by 0.
So-
Well, that equals
So what
0.
do I want to divide by here? I have 11n
Divide by
equals 0.
Divide by 11.
Divide both sides by 11.
So n equals 11.
N equals, what is 0 divided by 11?
0, because anything times or divided by 0 is 0.
N equals 0. Is that, can I have 0 as an answer?
Yeah.
Yeah.
It
Zero's a
could
number.
just be n. Since,
So n equals 0.
or
Yeah.
could you
N
just write-
is 0.
Could you just like write n